Welcome to Energy Innovations, a regular video series that explores the latest innovations in technology, digital, regulations, products, services, finance, and business models that are impacting the energy sector. Energy Innovations interviews entrepreneurs, energy companies, capital markets, and regulators to understand how the energy industry is changing.
Welcome back to Energy Innovations. My name is Geoffrey Cann, and today's topic is going to be on remote site monitoring. The oil and gas industry, particularly in the upstream, but not exclusively, has much of its facilities scattered about oil fields, often far from telecommunications networks, settlements, and I suppose that's just nature's way of teaching us geography, to go find the resource and bring it home. And I'm going to be joined today by Ian Cunningham, who is the founder of a company called Wave9 that has been innovating in this particular domain area. Ian, welcome to Energy Innovations.
Thanks, Geoffrey. Glad to be back having a chat with you again.
Yeah, I think you appeared on a podcast of mine some time ago, but the way technology evolves, the world changes quite quickly. So it's worth a catch up. But let's just unpack this whole remote monitoring question. I know that in your background, you've actually delivered monitoring as a kind of a career. So what is this problem area, and why has it been important to try and solve?
Yeah, well, my background is in wireless solutions, telecommunication software, but I've got a lot of colleagues that have worked in the energy industry, and one of the things that comes up quite often in discussions that we've had is, the process of inspecting remote well sites, and why isn't there more equipment out there, more solutions that automate the overall process of just managing all the assets that are part of the upstream production environment. And so Wave9 came about as a result of some of these discussions, and we identified a number of areas where the industry could really benefit by just automating the daily inspection process that happens. So moving from the existing status quo where somebody might be driving out to that well site every day to check to make sure that it's operating, look for leaks and everything. By automating that, by providing them with remote monitoring, you eliminate the need to drive those trucks out on the road. That's has an impact on the safety of those workers, right? So by reducing the amount of driving time and exposure to these hazardous areas, it's a big benefit to remote monitoring. In addition to that, identifying leaks by using camera technology that we have that goes out at the site and automatically takes photos of a wellhead area. And then by processing that in AI and automatically presenting back sort of an alarm to different sites, we can identify ESG challenges or factors like that. And then overall, by automating the process, it's just much more cost effective if you can reduce the amount of labor hours that go into just driving around and inspecting these sites, and really get that effort focused on the actual repair work, things that people need to really be involved in out there.
And what's makes this now technically an innovation? Like what's behind the ability to do things like remote monitoring?
Well, there's been attempts, obviously, in the past, and a lot of producers are using SCADA to collect general production information in from remote sites.
Right.
But the big change that's happened over the last number of years is the availability of the cloud in order to present data in a much more centralized fashion, data that can be collected from a number of different systems, but then shared between those systems to collect deeper insights. And that's really transformed how data is used. There is a big shift in the way that the information is collected. So instead of the very expensive individual SCADA installations, you now have the ability to install enterprise-grade industrial IoT systems that are encrypted end-to-end, secure, reliable, can provide that data into these systems in a way that is manageable in the way that enterprises expect. And then once that data is collected, you have a native platform for employing artificial intelligence and machine learning algorithms on top of that data in order to vastly reduce the amount of effort of analyzing, interpreting, and then acting on that data. So what we didn't have 10 years ago was all of those pieces in place, and you ended up with solutions that were browser-based, required field workers to be reviewing graphs and things like this, and it just wasn't really conducive to the sort of end-to-end automation or sort of roboticization of the process. And I think all those pieces now are kind of in the puzzle. So
yeah,
it's led to some really good advances that way.
Yeah, it just underscores the imperative of cloud computing as the foundation. You know, without that, much of this innovation actually can't even happen. And now let's just kind of look at this whole question of leaks, because this is a really fascinating area. How does a camera actually detect a leak? Like, because I'm trying to imagine, like, for the human eye, if it rains out, it looks like a leak. So what is the capability around that specific domain area of leak detection that's innovative in and of itself?
Yeah, so there are a number of factors, and when you look at the different types of images that come in, we have to have a very generalized approach to this. But a couple of examples are things like if there is a containment hood at the site, we can identify contamination that's starting to form inside of there. If there is a differential in, say, color between the wellhead itself and say a stream of oil that's coming down or something like that, and then on the ground, whether it's snow or just regular dirt and grass area or something like that, you have to take a lot of different photos of a lot of different types of situations, and then identify these sorts of color and shape differences. And by doing that, we're able to start to train the system to figure out what it should be looking for in those early stages.
So there's a machine learning algorithm that's working on in the background here that's taking the actual camera feed, and you're teaching it to be able to pick out of a visual image something that's amiss, which could be a liquid which shouldn't be there, or some other factor. Am I getting that right?
Yeah, that's exactly right. And so Wave9 now collects thousands of images a month. We pick through those and uh, sort of supervise or manage the training of that algorithm. And the wider we can cast that net, the better we get in terms of generalization. But then beyond that, we can also tailor the algorithm or the machine learning model to identify things with a certain type of site as well. So, if there is a containment hood, we can develop a model that's more relevant to sites that have that. If there's other equipment at the site, or if it's in a different type of environment, we can tailor a model towards those sorts of parameters. So it really kind of depends on what's needed that way. We're also working on gas leak detection. It's not in the field yet, but we've been looking at a couple of approaches there, both with IR camera sensors and the typical type of gas sensor that you have just on personal protection equipment and everything like that, right? To identify point sources of methane release as well. So this is something that we're looking at some research partners for too.
Yeah, once you figure out some of the ability to pick molecules off the ground, and you figure out how to do it out of the air, it's extendable. Let me go back to the machine learning and the algorithm though, because there's sort of an interesting element here. It's a bit like facial recognition technology that people hear about, except you're applying it to industrial infrastructure. If I'm a producer and I have a certain piece of infrastructure and you're training the algorithm on it, does that training mean that it will work on a very similar piece of infrastructure? Or do I have to start from scratch each time?
No, it's going to build every single training session that we do will build on its interpretation of what that looks like. So as you as a new customer to Wave9, let's say, would benefit from all of the previous quote unquote education that our system has learned over the last couple of years. And then as further data comes in, it's refined and refined in such a way that the accuracy just continually increases over time as more and more data is ingested. And we also offer that back. Like we see ourselves as a collaborative partner within the space. So all too often I find that there are other solutions out there that try to kind of lock down the type of data that they're collecting, but we don't see that as a really solid way forward for the industry. I think that there needs to be a lot of sharing and providing of that data back and forth between us and our client. So there may be other aspects where some of that information is helpful to the production process or something like that as well. But yeah, generally speaking, everything that we're interpreting just continually teaches that model to continually improve its accuracy over time.
And so the more that companies participate, the smarter these systems can get, and the more easy it is to then deploy it into new and other areas. Where does the actual interpretation of this visual data take place? Is it at the site, or does the data require a telecommunications point to kind of pull the data up to a cloud engine that's doing the interpretation? How does that piece of it work?
So technically, either of those options is possible. With Wave9, early on, we consulted with our lead customers and during an initial pilots and prototyping, and we said, what is the most important thing here? And cost was on everyone's mind. So the infrastructure, we decided that we were going to reduce the cost of the infrastructure that would have to be at the site as far as we absolutely could. And that meant that we would pull all of that data into the cloud, make the interpretation there. But then we send all of that down to an individual operator's smartphone. So there's a very simplified dashboard that they can use that drives their actions day to day. There's not many graphs or anything like that unless they really want to get into the weeds. But it's the type of thing where in about 5 seconds, you can flip through the screen of about 50 different well sites and get a feeling for which ones you need to be spending your time on. But the information is brought up and processed there and then sent back down to the operator. It is possible, if there are other systems on the site, to deploy models down to the edge to do that work.
Yeah.
But for us, cost kind of trumped out.
Drove the bus. And probably will continue to drive the decision making around these technologies. Is a great number of the wells out there where this technology probably applies. These wells are struggling under continual cost pressures. The rising cost to constantly deliver service is always a challenge. Now, you mentioned hydrocarbons and gas, but there's lots of chemical tanks out in the field. It's not just product. So what other things can you now detect with these visualization solutions?
There are some ways to determine tank level dependent on the type of tanks and things like that. If IR cameras are used, and we have partners that have direct tank level monitoring capabilities that we can tap if there's a requirement to combine that with the overall pump jack monitoring and operation. So there are some aspects to that, but we didn't design any of the sensors or direct measurement of that. We felt like that was a pretty well-established area of coverage within the industry already. So it was one of those things where we will work openly with partners to ingest that data and share it. And it could even be like a Bluetooth connection to a device on site, for instance. Some of the new stuff that we're looking at coming down the pipe will open up local wireless sensors like Bluetooth to do that. But there are some things that we will bring in from a third party that way.
Yeah, and I think that underscores again back to the collaboration. If a service or a solution's already well established, in place, working, and does not suffer from cost challenges or pressures. Just the industry's normal
Yeah,
requirement is just let it run. Like it's
exactly.
not you're not going to get any great advance in that fashion. Where it sounds like leak detection really stood out as a candidate for attention here.
It really did, because there definitely aren't any alternative automated solutions that are solid in the field for that. There are other camera systems, and it's a really good point about existing equipment, right? Wave9, we don't want to reinvent the wheel. We don't want to supplant existing infrastructure. That doesn't make any sense to us.
Hmm.
What our guiding sort of philosophy is how do we economically deploy automation technology to a very, very wide set of sites in the field, even very, very low producing sites like single barrel a day pump jacks and that sort of thing. We want to make it economical for every production site. And along with that meant if there are existing data collection systems out there, SCADA or cameras that you have already installed,
Yeah, you want
then
to plug
we
in.
want to work
Yeah.
collaboratively to just work on that data, right? So if that data is already being brought back and centralized, then we can interpret, say, the images through our AI. We can interpret the data that's come back if it's sufficient enough to determine other things about the health, let's say, of a pumping unit.
Mm.
And then we can take that and still display it in the very user-friendly dashboard that works so well for people in the field, right? So it's designed so that we can kind of take the pieces that matter, apply them in the places where they intelligently should be, and work as a partner on these bigger business challenges that the client has. Not try to lock them the way that it's been done in the past. We don't have any intention of trying to kind of lock someone into this entire stack of hardware and software, right? We just want to apply the right tools to the right places to get the job done.
Yeah, it's a very different way from how the industry typically approaches, but much more consistent with the Silicon Valley
Yeah.
digital model, digital thinking. Now, what do companies tell you is the underlying economic drivers that motivate them to want to do this? And I mean, you talked a little bit already about the cost of sending people around to visit a site. Can you elaborate a little bit more on the actual economic imperative that people articulate for you?
Sure. So I'll give a couple of examples. Our lead customer, one of the things that really drove them was during 2020, they were curtailing production, in the middle of COVID, and then started to bring some of it back online. And in one case, they had a field where they wanted to bring 76 wells back on. And they knew that they would either have to hire two contract operators to manage the inspections and that field, or the alternative was to go with Wave9. So what they were really comparing, in essence, was bringing these two contract operators on roughly at a cost of about $240,000 for a loaded truck operator and everything to manage those sites, or through Wave9, they could spend about $45,000 a year. So the ROI, given that kind of comparison, was just astronomical for them. It was over 400% by the time we looked at the labor savings, and then you have the reduced risk by being able to respond to a spill earlier, and then also the ability to find out if a well site goes down within an hour allows you to respond to downtime much quicker too, in a managed by exception type of model, right? So there's even a potential revenue benefit if you're reclaiming some of the unexpected downtime that you might have with assets as well. And now we're starting to explore things even beyond that, right? So we have a fairly deep amount of data that comes off of the power used at a pump jack,
Mm.
and we can start to identify certain mechanical issues and things like this. So we don't even know what the quantification might be yet of some of that exploration, right? But just the labor savings alone, that was huge. They moved from a daily to a weekly inspection with the existing team, and they just have three people instead of five managing that group of sites now.
Well, then the prize at that level, given, well, there's several related challenges here, but shortage of people means you're struggling to find people to do the job that you need. So now you can get far greater people productivity. But if you were able to retain people, now you can grow because you've actually got the human horsepower for you to take on more. So there's an economic swing here that's really intriguing. Can you just talk a little bit more about the regulatory and compliance dimension here? Because I assume under there would be reporting requirements around current status and state of infrastructure. Do these kind of solutions enable efficiencies there as well?
Yes. So, in fact, with the lead customer now, we've got about 150 sites being monitored. We have not had any reportable spills for that operator. There's been a couple of incidents where a packing leak started to form, and someone got out there within a couple of hours to shut the well down and start a cleanup on less than a liter of fluid that's just kind of in the containment or in the area around it, and can be shoveled up type of thing. There hasn't been any kind of significant event, so that is a huge factor and a really big win for us in the sense that we have identified about 5 incidents where a packing leak had begun to start forming, and a notification had been sent out. So that's a big factor, for sure. And there's kind of some other aspects of this as well. The safety of the sites. We are working now on the integration. We have the last equipment that we designed is set up for a Class 1 Div 2 installation with an interface into Class 1 Div 1 sensors, so you can have pressure, flow, temperature, things like this coming back off of the wellhead as well. And that's kind of the next critical piece to us. So there's some aspects that way too that factor into the regulatory question.
Yeah, so kind of a full suite, really, of things. Tell me, does the individual who goes out to the site, say the technology has raised a notification to say you may be experiencing a packing failure here? Does the individual going out to the site, do they require different job skills now to be able to carry out their responsibilities at the site, or is it just sort of they're just doing what they do? You're just directing them to the highest things to focus on.
Yeah, we designed the system to as much as possible just continue the same job. The goal of Wave9 was to enable operators to just work under the same set of responsibilities they have today, the same type of tools they have today. We wanted to enable them to just be able to review what's happening, kind of have a virtual presence at all the sites that they're already responsible for. And what we've heard back from the operators has been really interesting too. So one of the very first things that we were told was a lot of times, if you bring in a technology system, guys in the field might not like it because they're going to start looking at graphs and having to interpret data and try to figure out what's happening based on some kind of analysis. And that's not part of their job, right? Their job is go see what's happening and then just fix it, right? And people told us, I want to see it, I want to hear it. So we really took that to heart and designed the system around that kind of feeling of virtual presence. Everybody knows how to use a smartphone, and a simple app on the smartphone gave us a very easy way to get the information in front of the operator. And then when you look at it, you can see, just on your phone, you can see 10 sites listed on one page, and then you scroll up through 50, 100 sites and see color coded whether there's an alarm on that site, and then tap in just as deeply as you need to go. And if you don't need to, then you go through it really fast. And by doing that, some of the operators said, well, you know what, now when I do check one of these sites, I kind of know what tools to put in my truck. I know what I might need to prepare for, if I got to put in some particular personal protection equipment. I can prepare ahead of time before I go to that site. I know what I'm going into a little bit more, right? And so there's some peace of mind that comes from that. Through the winter, they've liked it because they don't have to be out in the cold checking on these sites or trying to get to difficult to reach sites in the middle of like spring breakup and everything, right? So we've had a positive response from a lot of people just based on the ease of use, right? And the very few changes that do have to happen for them to adopt the system.
And you mentioned that it is as simple to use as on a smartphone app, and everybody has a smartphone, which is true. Is there any generational issues lurking under this? I mean, a question I've often flagged when I speak with people is the view that younger generation will find this technology really easy to use. Well, my mom's in her 80s and she's using a smartphone. So, is there a generational divide here that crops up, or are you seeing this argument about generations is really a red herring now?
I think there's sort of two aspects to that question. So when you think about the user interface, to us, that's critical, right? And I feel like this smartphone has really leveled the playing field for a lot of that. So there is sort of a mentality just in the industry in general, right? About, well, this is how we've always done things. Do we really want to, change this or that, right? And and a lot of the time that comes down to just a bit of, I know my job now, and I've seen these things in the past, and I didn't like them in the past, but now I think things are very different. So we're hopeful on that side of things. The other side of the question is one of just general change management, and I don't think that this applies only to sort of the generational question. It's really for the industry in general. There's a challenge in operations to be able to adapt and move to newer types of data use, newer types of technology and working methods, with some agility that just isn't part of the sort of culture of the industry. And this is a bigger challenge for the industry in general. So those of us that come out of, you kind of use the word the Silicon Valley type of mentality, right?
Yeah.
My background being in telecom, I understand the importance of having sort of a 5 nines utility grade availability, right? And you need to make careful, planned changes to that type of system. At the same time, there are methods of working and adapting your operational processes, the technology that you're using, which can unlock a lot more agility, and it can still be done in that very careful approach using well-established frameworks now. And those of us that have kind of grown up in the software side of this, or the cloud and the big data type of industry, we have those skills, and we're anxious to talk with people in the industry about how to instill them and help them forward with their own teams to adopt these really good approaches, right?
Yeah, it's definitely a mindset shift is required here. Can you just elaborate a little bit as we kind of wrap this conversation to a close on where you see the future in this world of remote monitoring? Are we going to reach a place where all facilities start out with a remote monitoring view, and rather than having something retrofit? And where does this go? Because I mean, there aren't not a lot of limitations now when you start to think about what you could do once you've got data in the cloud and better technology.
Yeah, I think that the history of this, looking at other industries, kind of bears out that there are a lot of things where people feel like they're at the edge of something, they're leading, and in reality they're not. Someone else is out there doing something ahead of you. And there's been a lot of situations in other industries where somebody who felt quite complacent and comfortable as a leader ends up being supplanted by somebody who comes in and completely revolutionizes the way that operation is done from a digital first mindset. And I think that it's important to recognize that that's possible within energy as well, and that there are people out there with the skill set to move this forward very rapidly. And that when that happens, there are not only the obvious benefits, some of the things I've mentioned, right? Like cost reductions in the operations side, the safety benefits, the environmental benefits, but holistically, as you add multiple, Wave9s or multiple different companies that are helping with certain aspects, when they begin combining that data and collaborating, then there's all kinds of emergent technology benefits that come out of that none of us even know about right now. And when you start tapping into that, things move extremely fast.
Yeah, and it's going to be a very interesting world coming up. Ian, thank you very much for joining me on Energy Innovations today.
Thank you, Geoffrey. Great to have a chance to talk.
That brings to a close this episode of Energy Innovations, and we'll return shortly with a fresh episode. Bye for now.
Thanks for joining our latest interview on Energy Innovations from EnergyNow Media. Don't forget to hit that like button, subscribe, and share this video. You can contact us at info@energynow.com to book your appearance or to become a sponsor.